mean absolute deviation, standard deviation, variance. In this video, we will discuss measures of dispersion based on all observations, taking the same two sets of data from earlier videos. 5, 15, 15, 25. 10, 15, 15, 20. The arithmetic mean in both cases is 15. The values of deviations in the two data sets from the mean are -10, 0, 0, 10. -5, 0, 0, 5. If you observe, in both cases the total deviations are 0. This property that the sum of deviations, and therefore the average of deviations, about the arithmetic mean is 0 always holds. Therefore, the average deviation cannot be used to measure dispersion. We use the average of absolute deviations. This is called mean deviation. The mean deviation is obtained by the formula on screen. Sigma represents the sum total. X represents observations. X bar represents mean. N represents the number of observations. For the two data sets shown, the values of the mean deviation are 5 and 2.5. Now, let us look at standard deviation, that is more commonly known, and the variance. Standard deviation is the measure of the spread of the data. It tells how much the spread varies from the average. The standard deviation is the positive square root of the average of the squares of deviations.
Variance. The square of standard deviation is called variance. It is a measurement of how far a set of data is dispersed from the mean or average value. It is indicated by the symbol sigma squared. The properties of variance are: 1. Since each term in the variance sum is squared, the result is either positive or 0, it is always non-negative. 2. Variance always has squared units. Variance for the population dataset can be obtained using the given formula. Sigma squared represents the population variance. Sigma represents the sum total. N represents observations in the population. Xi is the ith observation in the population, and mu represents the population mean. Variance for the given sample dataset can be obtained using the given formula. Sigma represents the sum total. Xi represents the ith observation in the sample. X bar is the sample mean. N represents the number of observations.
Variance is closely related to standard deviation. The difference between the two is that standard deviation involves the use of square root in the calculations. If you observe, you will see that the variances of the two datasets are 50 and 12.5. The standard deviations are therefore 7.07 and 3.53. When compared with mean deviations, the standard deviation magnifies larger deviations. Therefore, a larger spread is better captured. Like the arithmetic mean, the standard deviation is also amenable to further mathematical treatment. Hence, it is the most used measure of dispersion.